blah 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 blah
Huh?
Well, I hope you don't think I sound like that guy. But the student had a good question. How do we know the continents move if we can't see it happen? There are 5 clues that can tell us. The continents are connected to big slabs of the Earth's crust. These slabs are called tectonic plates, and they move. The continents just go along for the ride. Have you ever noticed that South America and Africa look like they would fit together like pieces of a puzzle? They look that way because they used to be one piece. The other continents can fit together too and get in on this snuggle fest. That's because long ago they were all joined in a supercontinent called Pangaea. But after Pangaea formed, it split up and the continents slowly drifted to where they are today. Clue number 2 is going to take us back to South America and Africa. Right where it looks like the continents would fit together, we find the same rocks and fossils. When Pangaea existed, these rocks and fossils were part of the same continent. But Pangaea split up, and today these rocks and fossils are separated by the Atlantic Ocean. We see similar evidence in North America. Right where it matches up with Northwest Africa, we find the same rock type, because they were once joined. Today, they're also separated by the Atlantic Ocean. Today, the climate in North America gives us hot summers and cold winters. Definitely not tropical here. But fossil evidence shows us that it used to be tropical. For example, we can find fossils of palm trees and dinosaurs, things that could only live in a tropical climate. Tropical climates only exist in places that are close to the equator. How could it have been tropical here? We think North America used to be on the equator and was much warmer then. It has since moved north to where it is today. If the continents weren't moving, we wouldn't find tropical fossils here. We can find similar evidence in Africa. Today, Africa is hot because it's on the equator, but it wasn't always hot. Glacial striations can be found in South Africa. Striations are scratches left in bedrock when a glacier moves across it. Now, if striations are in Africa, then glaciers must have been there. If glaciers were there, then it must have been much colder than it is today. Now, how could it have been colder? We think Africa used to be closer to the South Pole and has since moved north towards the equator. At the bottom of the oceans are divergent plate boundaries called mid-ocean ridges. Tectonic plates separate here. Here we're seeing the Mid-Atlantic Ridge. This is the boundary that has separated South America and Africa and North America and Europe. Now if you could actually see what was happening underneath these mid-ocean ridges, it might look something like this. Magma rises up underneath the boundary and separates. The crust is ripped apart, magma oozes up to the surface, cools, and makes new rock. This new rock is then ripped apart and pushed away from the ridge. This makes a pattern in the age of the rock. The farther it is from the ridge, the older it is. And the youngest rock winds up right at the mid-ocean ridges. If the seafloor wasn't spreading apart, we wouldn't see this pattern. This last clue also comes from the mid-ocean ridges, and it has to do with the Earth's magnetic field. The magnetic field is generated by Earth's outer core. We're not sure why, but every now and then, the Earth's magnetic field flips. North becomes south, and south becomes north. There's evidence of these flips in the ocean floor. That evidence wouldn't be there if the ocean floor wasn't spreading apart. When certain minerals crystallize in the magma at the mid-ocean ridges, they align with the magnetic field. When the field flips, they align the other way. This results in a pattern in the rock of the seafloor. Again, if the seafloor wasn't moving, this pattern wouldn't exist.